Hansen.
And I'm Claire Myers.
And this is a presentation on programming your robot, the differences between LabView and RobotC.
So we guys are going to get you started a little bit of background before we start all the programming stuff, so about what autonomous is and what teleop is. So autonomous is the first 30 seconds of every match. You can't use any controllers during this period, and this means that everything has to be pre-programmed into your robot. There are certain tasks in autonomous that are different from the ones in teleop or the rest of the match. And I believe that this is the most difficult part of autonomous, is that there's 3 other robots running at the exact same time you do, and they could bump your robot and like throw off your program.
Before I tell you about teleop, you guys, most of you are rookie teams, so you probably don't know that once you put your robot on the mat for autonomous, you can't add attachments or pick it up or touch it, even before teleop. And teleop is 2 minutes and 30 seconds long. It is the part of the match that is driver controlled. During teleop, you can try and do different missions, like putting a block in a basket to earn points. And the last 30 seconds of teleop is the endgame, which has its own set of tasks too. Not only will you need to program the joystick, but you will need to program the buttons if you're planning on using any attachments. So, flashing the Samantha routers and Bluetooth. So I know when we were a rookie team, we had a lot of trouble with connecting to the Wi-Fi. So basically just ask people for help in your other teams and stuff like that, because those people are nice. And with flashing the Samantha, you want to keep your Samantha up high on your robot for better Wi-Fi connections. You also want to have it easily accessible so that when you are flashing it, which is plugging a USB into it, that you can do that easily. Also, you want to be able to easily press the red button on the top. So routers and USB. Routers are the things that put out the Wi-Fi, and the USBs are the things that you plug into your Samantha when you're flashing it. It has the router address onto it, so it tells your robot which Wi-Fi to connect to. Bluetooth is what we use for practice in our team. It's basically a direct connection from your NXT brick to your computer. So the reason that they don't use that in competition is because most devices like cell phones and stuff put out their own Bluetooth signal, so it interferes with the competition. And then the master controller in competition is basically just the computer that connects all 4 robots to the same Wi-Fi during each match. What are virtual worlds? Surprisingly, in virtual worlds, you do not need a physical robot. You program an animated robot which is able to move around in a virtual version of the game. There will be one coming out in a few days of the game for this year. You can basically learn to program your robot before it's built. The only problem is you have to choose one of their pre-designed robot bases. And this is a great way if you want to get a head start before your team is talking about robot design to show them exactly what you're thinking. And it's also a nice way to have your programmers be involved with the robot design.
Is that something that's available on the FTC site?
Virtual worlds are on RobotC, so they're not used in LabView, but they're on RobotC for you to use.
And it's available on first.
This is just a sample code of LabView. LabView is generally easier for beginners because it is a textually based program.
It's a visually based program. So the pros of LabView is that LabView is easier for beginners because, again, it's visually based, so it's easier to see the flow of the program. The software is free to download, and it comes with the FTC kit of parts. And LabView is legal in FRC, so if your team is ever looking into transitioning from FTC into FRC, you could use the software in both. And then finally, LabView is good at multitasking.
But there are also many LabView cons. When using controller, the program and the robot flows. And when LabView takes up a lot of computer space, so not as many programs can be stored on the brick. It's hard to debug, and it's very difficult to solve problems. This software is difficult to keep organized, and when adding new commands to a set program, you can't change the names of the preset variables.
And then this is a sample code of RobotC. It is a little harder for beginners because it is textually based and not visually based.
RobotC has a lot of pros. There are many helpful debugging tools inside RobotC. It makes it easy to find problems in the program. RobotC has a large amount of online help, so most questions can be answered online. It's good for learning how to learn to program different parts of your robot. Video tutorials, community forums, and detailed help files are also great tools to use for when you're programming. The time between pushing a button and moving a joystick is a lot faster than LabView. Bluetooth messaging is 50% faster than NXT. In RobotC, there is a lot less memory use than LabView because it's textual.
So the cons of RobotC is that when using cons of RobotC are that it's not free and you have to buy it in pieces. So the FTC kit of parts does not come with it. You have to buy that separately. And RobotC is more difficult for beginners because it's again texture based, so you kind of have to learn something new. And it's harder to see the flow of the program when it's textually based. RobotC is not as good as LabView at multitasking, and again, it does not come with the FTC kit of parts. Do we have a question?
Yes. What does multitasking mean in this context?
Alright, well, robot, you can't, Kristen, you don't know who
Okay, but multitasking is basically when it's doing two commands at once.
So it's like running your wheels while putting up an arm is multitasking. So it's basically when your robot is running. Question?
You had on the other one that was legal for FRC. Is this also legal for FRC?
No, unfortunately this is not. LabView is actually legal in FTC, so some people might have used it. It's not very common in FTC, but it's also legal in FRC. Yep.
So is RobotC still good at multitasking, or is LabView better at multitasking?
LabView is better at multitasking. RobotC is still fairly good at it, and it's still able to multitask. It's just LabView is better.
I think it's easier to see in LabView because you've got that graphical vision of it, so you can actually see the two lines of code that are going to be going at the same time. Where you just have to be able to program that in with RobotC.
So this is a sample code for RobotC. Again, we're a RobotC team, so we're just going to show you some RobotC sample code today. But the first sample program here is an autonomous program. The first step of this program clears the motor encoder. The motor encoder is what tracks the amount of rotations wheels turn. And the next part says while the motor encoder is less than 4,000, the robot will continue to go forward. When it's more than 4,000, the robot will stop. Step 2 says that while the gyro sensor, which helps the robot make more accurate turns, is less than 350, it'll keep turning. And when it's more than 350, it'll stop. And then basically step 2 is repeated again, except that when it's less than 450, it'll keep turning, and when it's more, it stops.
And then this is our second example of programming. This is a simpler program because it is your joystick program. And in the beginning, it's just setting the driving control. We used it so that the motors move with the movement of the joysticks. Next, we set the arm control. Secondly, if the right button is pressed, the arm raises. And if the right trigger is pressed, the arm lowers. And lastly, the intake motor, which is the part of the robot that grabs blocks. If the left button is pressed, the intake rotates inward. And if the if the left trigger is pressed, the intake rotates outward.
So these are the pros and cons of both LabView and RobotC. We just kind of put them up here so you guys could see both of them at the same time. If anyone has anything to add to RobotC or LabView, right now you can say them or raise your hand and we can call on you.
I have a little, my team used LabView last year. I think between the choice, I mean, it's what your students are most comfortable with and the technical people that you have to help, so your technical mentors. We used LabView last year because our programmer had previous experience with graphical languages, so she felt more comfortable going that way. I'm not trying to sway anybody, just the experience we had is we weren't able to find as much support for LabView, like sample programming, people who were able to give us examples online. So for us, that was kind of the big thing. But if you have somebody who knows LabView, especially someone who does it professionally, I know that there's a lot of teams who've been very successful with being able to program with LabView just because of that. But this year, I think we are going to change, but again, that's our choice. We don't want to influence you. But my husband and I are both programmers, so we're a little more familiar with the textual languages.
Yep.
Why did you guys think about C?
The reason we picked RobotC is because we thought it was a little bit more like what they use in industries. They do use both LabView and RobotC, but there's RobotC version of C and C++ and Java, and they're all textually written ones. So most people do use written out languages.
And another thing is we were searching online. Many people said they prefer RobotC because some of their mentors have used RobotC. Like in a lot of technology fields, people use textually based. So some of the mentors actually knew how to use C and RobotC, so that definitely helped.
Anyone who's used LabView before talk about the lag between the button pushes and?
That was one note that I wrote down. We didn't actually notice any lag last year, so we didn't see it.
RobotC, it's just you press your joystick and right away it does it, and I think there's like maybe a second or two that LabView waits a little bit.
And we didn't experience
Yeah.
that. Oh.
I guess I also want to mention for anybody that wants to use LabView, there are a lot of companies also that use that, just so that that doesn't get left here, that you won't get hired.
I've talked to a few other
I know some.
other people in the community at tournaments who do use LabView, and they were able to tell me exactly what to do in some of the active situations we were having. So if you have a technical mentor that's familiar with it, I would definitely recommend going that way, just because it is something that's more up and coming. I think I grew up with textual and resistance, so that's probably my companies, but I think with the younger students, that if you could find somebody that can actually help with that, it's a strong choice.
I'm fusing. Okay, I'm guessing the LabView is very similar to the one they normally use in FLL.
Yeah, it's a lot more simpler because both of them are visually based, and I think LabView is more of like a drag and drop program. It's easier to see the flow.
Is that how I'll use the Lego?
Like Mindstorm, you can also use LabView in FLL though.
And Mindstorms is actually built on LabView. LabView's code goes under it, and then Mindstorms is built on top of it, so it's just going down a layer in the code.
Is there anything else before we move on?
Do you get a feel for last year how many teams used one versus the other?
I think we saw a lot more was we were using RobotC. We didn't personally know any that had LabView teams, but obviously there are
There's a
some.
few. I think, did you guys, you and Shirts, in fact, did you guys use LabView last year?
Yeah, use LabView.
And did you guys have a successful time on it?
Yeah, I didn't feel like LabView was as strong as RobotC, but I didn't notice any lag issues.
So, if you turn on somebody who's technical that can understand it and kind of understand and graph a little bit different.
We did have a tough time finding teams to help us, present, so that might be an indicator of how many.
I ended up running into more teams as the season went on, so I know at the state competition, I know at least 4 teams that were there. And they're probably more, we're stickers sitting a little bit happy.
All right, we're gonna move on. We can have more questions and comments at the end of the presentation.
Alright, we gathered some programming tips for you guys. So first, find out what your team wants the robot to do and what tasks you want the robot to accomplish according to the robot design.
So what our team does at the start of the season is that we make a list of all the things that we want our robot to do in the order we want to complete them in. I know that helps a lot so that we have an agenda during the season.
You should comment about everything. Comment every action your robot completes. It makes it easier for others to read and understand what your program does.
I'm not a main programmer, and commenting helps a ton. These two are the main programmers, and when they comment, it helps me understand the program more. So if the programmers are missing that day, people can step in and still work on the program with the comments.
Alright, keep organized and try to write things in order and keep things separated out. It's easier to read and develop.
Indenting is huge. Make sure you always want to line up, if you're using RobotC, your parentheses, because then it's so much easier to literally see, like, if you're missing a parenthesis, you don't have to go through, like, your entire program to find it. It's just, like, you look through the lines and there's one that doesn't have a second parenthesis.
So don't be afraid to ask for help. Programming is tough and you will need help at some point.
So I know we have 9 other teams in the EM program, and in our rookie year, we asked a lot of questions to them. Teams were very nice, so just ask them questions if you need help.
Learn the basics before you try to program the more complicated things.
Learn how to get your robot to go forward, to turn. Even try using sensors. Learning how to use sensors helped a lot. We actually personally did it last year when we were first learning how to program, and it helped so much.
Change one thing at a time, so if something goes wrong, you'll have a better idea of where it went wrong.
Okay, so again with the comments, then you want to comment everything. So again, if someone's gone, that you can tell what someone changed, so you don't try to change it again, and you know what things you changed the previous time.
And then do things in steps. Map out what you want a robot to do, then do one step at a time. Save often, and the more you save, the better chance you won't lose any important pieces of the program. And use version control too. Guys, you want to talk about version control?
Versioning is basically if you change something major on the program and you don't want to lose the program that you're on right now, you basically make another version of it and put the same code over there and change whatever you want. So if you make a mistake on the new program, you can always go back to the old one.
What do you guys use for version control?
Version control we basically do is like save as, and then we just have two separate programs. And then we thought you guys should know that RobotC has a new upgrade. It's 4.1. RobotC's graphical languages has been improved, and there are also more colors and commands to use in 4.1. The new upgrade has given initial support to 12C devices, which includes EV3 devices. EV3 is like a new version of the NXT brick. Just to let you guys know, you can't use EV3 in the competition this year, though. And lastly, 4.1 has given needed support to the N motor encoder and the synchronization of motors in virtual worlds. And these are our sources. We also wanted to give a shout out to the team that Q is Silent, who's also an Egan team, because they helped us work with us on our presentation.
And then are there any questions
or comments?
I have a question. Inside the virtual world, can you manipulate several different robots or only one robot?
It's only one robot at a time.
Okay.
Can you build a second robot with parts that you already have at your own place to, say, test robots that bumps into it at your own home?
Yeah, it's totally fine.
How exactly do you program model of your robot into the virtual world? Do you use something like a modeling program?
Well, you can't put your own robot into virtual worlds. You have to use pre-programmed ones, and they have different sensors on them.
Right.
You can use that, but you can like do models of your robot outside of virtual worlds, like using CAD, which is computer-aided design.
And then in virtual worlds, you just use program on RobotC. Then you compile and download your program to virtual worlds, and then you can use it on the robot.
Right.
Another question. Is the NXT brick right? Right first?
It's not provided at first. You have to buy it with a NXT kit, or then buy it separately from that.
Oh, because I already have an EV3. Because I already have an EV3 brick at my home.
Yeah, you can't use the EV3 this year in competition, though. The other thing.
If you had an old NXT that previously ran a different program, how would you convert it so it can use something like RobotC?
It's the same thing. You just compile and download the programs, and they should work the same way as like NXT Mindstorms.
Right.
How much does RobotC cost?
Not sure. Isn't it in the range?
$50 for a single seat for a year, $80 for a special license, and that sort of
Thank you. Thank you.
Actually, on the RobotC, I'm pretty sure sometimes the school buys a license and then lets the students use it. I think I heard that somewhere.
Yeah, you probably. I think you can do that too. Yeah.
I think we should wrap it up. We should wrap it up and go to the next.
They can ask questions on the way out.
You guys can ask questions on the way out if you have questions.